So 4.6, rational functions and models. I'm gonna do on Tuesday. All it is all a rational function is two polynomials being divided. So we've done polynomials. Yes, it's the one with the highest degree and descending powers, and we saw lines, parabolas, cubics, quartics, quintics. They can go on and on, but it's one of each one of those kinds divided by another kind of a polynomial. And obviously, your denominator can't be zero because you get an error. The domain of the rational function includes all the reals except the zeros of the denominator, again, because we can't divide by zero. Excuse me. The graph of a rational function is continuous except at x values where the denominator, which is q of x, is equal to 0. So vertical asymptotes. Here we go. So we have this function here, and the vertical asymptote is this imaginary line not part of the graph. And since it's a vertical line, we know that it's going to be x equal to, and in this case, it is x is equal to 2. So you're going to be hearing this in calculus, for those of you headed that route, and in business calculus next semester for some of you. So here it says, let me underline, as x approaches 2 from the right, f of x increases without bound. What does that mean? So here my x value on the graph is 5. Here my x value is 4. So if you notice, I'm approaching to 2 from the right hand part of the graph. Here x is equal to 3. And then even though here maybe x is equal to 2.5, and as much as I want to get close to, this is going to be headed forever to infinity. So the notation for this, all of this actually, is going to be as x approaches to 2 from the right hand side. So the right hand side is positive here. Then f of x is headed towards infinity. That's how we write it. Take a look at this one. As x approaches 2 from the left. So here's x equal to 2. And from the left, I'm on the left-hand part of the graph. So here I'm at x equal to -5, -4, -3, -2, -1, 0, 1, 1.5. And I'm going to try to get to 2, but I can't because of that vertical asymptote. But my y values are going to be headed towards negative infinity. So as x approaches to 2 from the left hand side, that's how we write a little negative, f of x decreases without bound, means that it's headed towards negative infinity. Okay. Horizontal asymptotes. So this dashed line that is not part of the graph is technically where your y value is headed as your x's go forever to the right and forever to the left. So here we go. Let's do this notation here. It says as x decreases, the graph gets closer and closer to y equal to 1. So here, let's say we're at 0. And then here it's at, so here at 0, my y is 0. Here at 1, -1, excuse me, my y is a half. And here at negative 1.5, it's like at point maybe 7. And here I'm getting closer and closer to 1, but again, I'm never gonna reach it. I'm never gonna quite reach it. I'm approaching it, but I'm never gonna actually reach it. So this notation is, as x decreases, is as x heads towards negative infinity, which is forever left, the graph gets closer and closer to y equal to 1. So this is gonna be f of x is headed towards 1, because it gets closer and closer to, it doesn't equal to 1. But here this y equal to 1 is the equation to this line. That's your horizontal asymptote. So now let's do this one. As x increases, the graph gets closer and closer to y equal to 1. So as x increases means as x heads towards infinity, because it's headed forever right. So I'm going to put that here. F of x is approaching to 1. So just a little tidbit of what's gonna be in your future, so that we're ready here for it, if in case that's where we're headed. Okay, so finding vertical and horizontal asymptotes. So it says let f be a rational function given by, written in lowest terms. So this is important here. So if it's not in lowest terms, we need to simplify. So the vertical asymptote says to find a vertical asymptote, set the denominator equal to 0 and solve. If k is a 0 of the denominator, then x equal to k is a vertical asymptote. Caution, if k is a 0 of both q of x and p of x, then k represents an open circle or a hole. So let me explain. So before I even do horizontal asymptote, let's analyze the vertical asymptote for this example here. So okay, so we have this equation, and I'm gonna rewrite here, or insert, it's technically f of x is equal to this function. And it says find any horizontal or vertical asymptotes, state the domain of f, and we're not gonna graph it in the interest of time. So that means we're only gonna be interested, for this course anyway, steps 1 and 2, and we'll use Desmos to help us graph it. But step 3 and 4, we'll leave it for pre-cal here. All right, step 1, find all the vertical asymptotes. Okay, so vertical asymptotes. Reading back up here. Let me erase. So to find a vertical asymptote, set the denominator equal to 0 and solve. And it says if k is a 0 of the denominator, then x equal to k is a vertical asymptote. However, caution, if k is a 0 of both the denominator and the numerator, then k is an open circle. So the key here is to factor to find the zeros, just like we've done before. Okay. So we have x squared plus x minus 6 over x squared plus 4x plus 3. The numerator is factorable into x plus 3 times x minus 2. And the denominator is factorable into x plus 3 times x plus 1. So if you notice, these two factors are the same. So I'm going to put it here since x plus 3 is a factor of both the numerator and denominator. We have an open circle, sorry, at, we set the factor equal to 0. We solve for x at x equal to -3. I'm going to add something else to find the y value of the open circle. Simplifying the expression and substitute x equal to -3. So simplifying the expression means the following. These two simplify to 1. And so wherever I see an x, I'm going to put -3. Excuse me. So -3 minus 2 is -5. -3 plus 1 is a -2. Negative divided by a negative is a positive. 5/2 is technically 2.5. So far, for graphing purposes, I have x and I have f of x. I know that at x equal to -3, so I'm going to put it in this color here. At x equal to -3, the calculator would give me an error, but it's actually an open circle. Equal to 2.5. Let me zoom in here. So at -3, 2.5 right here, I have an open circle. Now, this other, so now what's left, which is this denominator, I'm going to put here to find, and I'm writing too big. Hang tight. To find the vertical intercept, the vertical asymptote, my bad. Set the remaining factor in the denominator equal to 0. So that means I have x plus 1 is equal to 0, which means that x is going to be equal to -1. So at x equal to -1, I'm also going to have an error on my calculator, but that means that I'm going to have so vertical asymptote, I'm just going to put parentheses of vertical asymptote. V for vertical, A for asymptote. So at -1, x equal to -1, I have this right here. So we found vertical asymptotes and open circles. Now horizontal asymptotes. So what do the instructions say for horizontal asymptotes? So it says if the degree of the numerator, so we're looking at the numerator, is less than the degree of the denominator, then y equal to 0, which is the x-axis, is going to be your horizontal asymptote. If the degree of the numerator equals the degree of the denominator, then y is equal to a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Those two divided again will give you your horizontal asymptote. The third option is if the degree of the numerator is greater than the degree of the denominator, then you don't have any horizontal asymptotes. It's called either a slant, it's a line with slope, which is a slant line, or an oblique asymptote. We can always find them by dividing the numerator and the denominator using longhand division or synthetic, and the asymptote is just the quotient without the remainder. All right, so this one right here, I'm going to go with this. So for the horizontal asymptote, really I only need to look at this right here. So I'm going to put horizontal asymptote in blue, so you can see where the connection is. So I have x squared over x squared. Looking at these two powers here, I have that 2 is equal to 2. Therefore, I need to look at the coefficients in the front, and they both in this particular instance are understood ones. Therefore, here my horizontal asymptote is y equal to 1 over 1, which is just 1. So zooming in on my little graph here, at y equal to 1, I have a horizontal asymptote. So this is y equal to 1, and this one over here was x equal to -1. And that is step 1. Step 2 is to find all the intercepts. So I need to find x and y intercepts. And I'm running out of space, but I will make this work. So to find, so this is technically step 1, everything that we just did so far, and now we're gonna do step 2. So to find the y-intercept, x is equal to 0. So I'm gonna have 0 squared plus 0 minus 6 over 0 squared plus 4 times 0 plus 3. And that's going to give us negative 6 over 3, which is negative 2. So my y-intercept is 0, negative 2. So here I'm going to see what eraser I have, the big one. I'm going to adjust this so I can keep track of the table of values that I have. So x, f of x, this is 0, negative 2. So zooming in here, 0, negative 2 is right here. Zooming back out. The last thing we need to find, again, just for this course, will be the x-intercepts. So to find the x-intercepts, our y's are equal to 0. So we have f of x equal to, so it's going to be 0 is equal to x squared plus x minus 6 over x squared plus 4x plus 3. So I want to solve for x. The first thing that I see is that we're dividing by all this crap. So to get rid of dividing by all that crap, we're going to multiply both sides by all that crap. What do we do to one side? We do to the other. And so thank goodness we're multiplying by 0 on the left side, because technically on the left hand side 0 times anything is just 0. And on the right hand side, the whole point of multiplying by x squared plus 4x plus 3 is that these two parentheses simplify to 1. And 1 times x squared plus x minus 6 is just x squared plus x minus 6. And this is factorable into x plus 3, x minus 2, like we did up at the top. And the last thing is that we set each factor equal to 0. So I'm going to have x plus 3 equal to 0, x minus 2 equal to, x minus 2 is equal to 0. Just doing it again, sorry. Just need to write a little smaller or zoom in. X minus 2 is equal to 0. So if I solve this, is going to be x equal to negative 3. So I'm going to have negative 3 comma 0. And this one right here is going to be x is equal to 2. So I'm going to have 2 comma 0. So negative 3, 0 and 2, 0. If we notice, at negative 3, we already have an error, open circle at 2.5. So unfortunately, all the work that we did here for this one was a little bit meaningless because it doesn't count. We have an open circle. We can't have two things happening at the same time here. And the other one is 2 comma 0. So we have 2 comma 0. So 2 comma 0 is right here. And so for our purposes, this is going to be our function here. Again, hovering around those asymptotes, vertical and horizontal. And this is definitely a graphing calculator appreciation. This one does give us everything that we need. Sorry that I didn't have it open already. Oh no. And let me tilt it this way here so we can see. Sorry about that. So I'm going to have x squared plus x minus 6, all of it in parentheses, because I need to divide all of that. No. I need to divide all of that. So it's a parabola divided by a parabola. So x squared plus 4x plus 3. And so this is technically what we have. So unfortunately, I did finish saying a couple of seconds ago that it's a graphing calculator or Desmos appreciation. But if you notice, we were able to identify the open circle. And just by looking at it, unfortunately, Desmos doesn't give you the open circle. But at at -3, there you go, you see that undefined, that little open circle there. But everything else it does give you, but that undefined, or again that open circle, we'd have to find it algebraically, because Desmos unfortunately doesn't give it to us. And even if I were to zoom in, it still doesn't want to. Right there at 2 undefined. It doesn't want to, it doesn't do it. It just doesn't do it. But